In this chapter, we will study coordinates of a plane. This is part of analytical geometry. The analytical geometry is very important for understanding calculus. In analytical geometry, the whole uh, plane, which consists of several points, here every point in the plane is assigned coordinates. In layman language, we can say that each point in the plane shall be having an address. To achieve this purpose, what is done? There are two lines, one horizontal line, this is called x-axis, and one vertical line, this is called y-axis. These two lines are intersecting at 90 degree. The horizontal line or the x-axis, its value increases as we go towards right. 1, 2, 3, 4, 5, 6, like. And if we go towards left, its value decreases. Similarly, for the vertical line, which is called y-axis, as we go up, its value increases. 1, 2, 3, 4, 5, 6. And as we go down, its value decreases. The point where this x-axis and y-axis intersect, this point is called origin. Now see, this is our x-axis, this is our y-axis, and this is the origin where x-axis and y-axis both are intersecting. Now these two intersecting lines, they divide the whole plane into four parts. 1, 2, 3, 4. These are called quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, how a point is designated in the plane? Suppose there is a point x, y. Now, what this x, y means, how it is designated. Now, from this point, draw a perpendicular to the x-axis. It intersects the x-axis here. Similarly, draw a perpendicular from this point onto the y-axis. It intersects the y-axis over here. This is our origin, where the value of x is 0 and the value of y is 0. Now the first point, the x coordinate, is the measurement along the x-axis. So from this origin to this point, this measurement is, this distance is x. It is written here. And the second point is the measurement along the y-axis. So from this origin up to point here, this is y. So we will further study it with other examples. See this point. Now draw a perpendicular on the x-axis. It intersects here. Similarly, draw perpendicular on y-axis. It intersects here. So first point we have to write along the x-axis. So from the 0 origin to 1. So this one we are writing here. And the second point we have to write along the y-axis. So from here up to 4, because this point, the perpendicular from this point is intersecting at 4. So this point becomes 1, 4, and it is put into brackets. It can be given some name also, like point P or point A or whatever you like. Now we'll see some more examples. Similarly, you see this point. See here, see any point which is on x-axis, it would not have any vertical distance. So if a point is on x-axis, its y coordinate shall be 0. Similarly, if there is any point on y-axis, it will not have any distance along x-axis. Its x coordinate shall be 0. So for this point, x coordinate is 0, and when we go from origin to this point along y-axis, this distance is 1. So this we are writing 1 here. We'll see some more examples. So see this point 3, 4. Perpendicular from here to the x-axis, perpendicular from here to y-axis, it will intersect here 4. So the measurement along x-axis is 3. So 3 is written here, and the measurement along the y-axis is 4. 4 is written here. So this point becomes 3, 4. Now see this point. From here, draw perpendicular on the x-axis. It intersects at 4. Draw perpendicular from here to y-axis. It intersects at -4. So along the x-axis, it is 4. Measurement is 4. 4 is written here. Along y-axis, it is -4. -4 is written here. Similarly, this point, see, its distance from origin to this point is -4. Along the x-axis, -4 is written here. And because this point is on the x-axis, it does not have any vertical distance. So vertical distance is 0. 0 is written here. So this way, any point in the space can be represented with coordinates, x coordinate and y coordinate. This x coordinate is also called abscissa, and this y coordinate, second part, is also called ordinate. This whole system of giving a designation to a point in a space is called Cartesian coordinate geometry. It is in honor of mathematician Descartes, who contributed a lot in the field of analytical geometry. So that's all in this topic.